Let's now tackle number 23 on the Amc 10B, an arithmetic sequence of positive integers. Be careful here, it was originally missing from the problem. Has greater than or equal to 3 terms, initial term A, and common difference D, which is at least 2, right? It's greater than 1, so it's at least 2. Or it's Carl wrote down all the terms in the sequence correctly except for one term, which is off by 1. The sum was 2, 2, 2. So if it was off by 1, our sum must be 2, 2, 1 or 2, 2, 3. We've got two possibilities. And we know the sum of terms in our arithmetic sequence formula, right? A plus n minus 1, a plus n minus 1 over 2d. That's the average term times n equals 2, 2, 1 or 2, 2, 3. So the key thing to know here is 2, 2, 3 is actually prime. Now, how could you do this? How could you check? Well, 2, no. 3, no, because 7, sum of digits 5, no. 7, well, it's 210. 210 plus 13, that's not divisible by 7, so no. 11 is 220 plus 3, 3 is not divisible by 11. 13 is 130 plus, it's going to be what? 130. You can write it as 130 plus 91 plus 2. 130 and 91 are both multiples of 7, but 2 is not, so 13 also no. And now we don't have to check any more primes. Why? Because in general, if we have a number 2, 2, 3, it's impossible and it's not prime. We have to have at least one prime factor that's less than square root 2, 2, 3. Because let's say you have two prime factors that are both greater than square root 2, 2, 3. Their product will be not 2, 2, 3. It will be bigger than that. So there has to be a prime less than square root 2, 2, 3, which in this case is, it's going to be slightly less than, it's going to be less than, a little bit like more than 14. And we've checked all the primes until 14. So this is prime. 2 to 1, well, there's a nice little trick here. This is 15 squared minus 2 squared, right? 2 is 25 minus 4, which is just 15 minus 2 times 15 plus 2. So 2 to 1 has a prime factorization. So the key thing to notice here is that this may not actually necessarily be an integer. It could be a half integer, right? Because we have something divided by 2 over here. So 2 to 3, the only real possibility is if n is 2, because then this can be a half integer. But this doesn't work because of this condition. So clearly 2 to 3 has no possibilities that work. Now what about 2 to 1? 13 times 17. Now we've got a few possibilities here, right? We can have 13, 17. We can also have 17, 13. And there also are some half integer possibilities. Like for example, n, let's say is 26. And then this thingy over here is 8.5. But notice that that doesn't work because of the fact that if n is 26 and all terms are positive, the average term is going to be way bigger than 8.5. It's going to be at least 13.5, right? This is the smallest sequence we can have with 26 positive terms. And similarly, like if n is 6.5 and then this thingy is 34, well, no, that's clearly not possible. N has to be an integer. This thingy may not be an integer. So our other two possibilities that we could have are, we also have 1, 2, 2, 1, 2, 2, 1, 1. That's like very silly possibilities. We have 26, 8.5. What else? We also have 34, 6.5. I'm just being completely, complete here, not leaving out anything really. And then we have 2 to 11 by 2, right? Or which is 110.5. So clearly this doesn't work. N has to be bigger than 2. This also doesn't work for the same reason. And if there's 221 terms, can the average term be 1? No, right? 1 to 2 to 1. It's going to have an average of at least 110.5. So that's also a no. 8.5 and 26, we already explored. 26 terms can have an average of 8.5. Similarly, 34 terms, this is the smallest sequence. It's going to have an average of bigger than 6.5. So we're left with two real possibilities here, right? So firstly, let's take the first possibility. N is 13. We then get a plus n minus 1 by 2 is 6, so 60 is 17. Second possibility, n is 17, so n minus 1 over 2 is 8. A plus 8d is 13. Key condition here, d is at least 1, and a has to be positive because of this condition. So let's say, which of these following values can allow for d to be at least 2. If d is 2 here, now a is negative 3, which doesn't work. If d is 2 here, then a can be 5. So does this work? Right, 5, 7, 9, all the way until, well, what's our value of n? Our value of n is 13. So 13 terms, so our last term is 29. We can check that this indeed does have a sum of 2 to 1. So now we just add 5, which is a. Let's do it here. We have 5 plus d. What is d? D is just, well, 2. So 5 plus 2 plus 13, and that is going to give us 20. So that's our answer. So this is actually quite easy for number 23. The key idea is just realize there's 2 possibilities, and then just look at the possible prime factorizations. And in this case, if you just assume this was an integer, you would have to deal with less cases. So these cases were kind of, the half integer cases are technically possible, so you sometimes could check them. In this case, you didn't have to, but it's still a good idea because there might be harder problems where this might be 8.5 or something, right? Because if d is odd and then this n is like, I don't know, 8 or something, now we have 7 halves times, let's say 3, which is not necessarily an integer. So I hope you enjoyed this video.